Let's take a look at for loops, which are one of the more powerful ways to loop through values. You'll remember our while loop looked like this. We asked the user to enter an age, and while the age was greater than some value, in this case 0, we did some work, and then we decremented the age. It's very common to have this three-part pattern. Set up a value, in this case age, test the value, in this case while age is greater than 0, do some work, and then decrement the age, or increment the age, or in some way change it so that the while loop will end. You can combine all three of those steps into the header of a for loop. The first argument to the for loop is your setup. Here we're describing an integer named age and we're initializing it to 5. The second argument, which comes after a semicolon, is the test, while age is greater than 0. Also a semicolon, and then the change, age decrement. Inside the body of the for loop is the work you're going to do. The logic of the for loop is initialize once, test, run the body, do the change, test. If the test is true, run the body, do the change, and repeat until the test is false, and then fall out of the for loop. And so if we run this, we should get 5 happy birthdays followed by a ta-da, which we do. A more common look to a for loop is to use a counter variable. And for historic reasons, that's often just the letter I. The reasoning behind this is interesting. It turns out that this goes all the way back to Fortran, an early scientific programming language, in which the letters I, J, K, and L were the only legal counter variables. In any case, it's common to initialize a variable such as I equal to 5, set some condition such as I is less than 10, and you'll find that most initializations are to 0, although that's not at all required. It's just very common. And then, of course, you're going to want to increment the age variable. By the way, there are 2 ways to increment the age variable using the increment operator. One is plus plus after the term, and the other is plus plus before the term. And they actually are different. We'll take a look at that difference in just a moment. In any case, this is a more common looking for loop. For int equal I is less than some value, increment I. And then we're going to run through the loop this many times. If you set it to 0 and say less than 10, it will run 10 times, because remember the first one is at type 0. And we can run that. And we, in fact, get 10 happy birthdays. The for loop will come in very handy very often, and is probably the most common loop to use. Let's take one moment and examine that issue of increment before the I and after the I. The first thing I'm going to do is comment out these lines of code, because we don't want our for loop to run. There are 2 ways to comment out lines of code. One is on a per line basis using the double slash. If I mark double slash, everything from the double slash to the end of the line is a comment. And notice that it turned green because Visual Studio marks comments in green. The other is to use slash star at the beginning of your comment, and then to use star slash at the end of your comment. And that comments everything between them. The nice thing about having 2 ways to be able to comment is that you can nest your comments. That is to say, I could start out here and put a comment with a double slash that says a for loop for counting happy birthday. Not a terribly useful comment, but a comment nonetheless. I can then nest that comment inside a star comment, /star to begin, // to end, and this comment is preserved within this entire commented out block. Then later, when I uncomment this block, that comment is preserved. A shortcut to commenting a number of lines is to highlight them. Let's get rid of this line. Highlight the lines you want to comment, and then in Visual Studio on your menu you should see a Comment Out the Selected Lines button, and when you click that, it uses the line comment for all of the highlighted lines. By the way, there's a corresponding uncomment to undo that comment, and that can save a great deal of time. Returning to the issue at hand, the difference between the prefix increment and the postfix increment, that is the one that comes after the variable, can be a little bit subtle. Let's look first at the prefix. We initialize a variable age to 35. We then set new age to increment age, whatever plus age is going to be. Well, plus age is going to increment age and then assign it to new age. So when we type this out, age will have been incremented to 36, and new age will be 36 because the increment happened before the assignment. And sure enough, they're both 36. If, however, we are to reverse those, and here we assign age and then increment it because we're using the postfix operator, age will start at 36, and that's what will be assigned to new age, and then age will be incremented to 37. And so when we run it, age is 37, but new age is still 36. So the net effect is that the prefix increment operator says increment and then assign, whereas the postfix operator says assign and then increment. In the case of our for loop, it doesn't matter which we use because there is no assignment. We're just incrementing the value. It is common, although not required, to use the prefix operator in that case.